And hello, welcome back to this OpenFOAM. Okay, let me get rid of that. Yes, welcome to this OpenFOAM video. So we are trying to run our PimpleFOAM simulation. There's something that actually went wrong. If you take a look at the original file and you go into new T, we had a calculated type boundary condition at the wall, and that actually gave us an error just now. It was giving us an error, so I need to change this to new T. You can use KU or anything. I'll use K wall function, or maybe I'll use U instead. U is fine as well. Okay, so if you ever forget, just go to PimpleFOAM, list scalar BCs, which is the boundary condition. You can see the types here. I can use U, I can use K, but in that case I was using K. K is the turbulent kinetic energy. So if you're using K omega SST, K epsilon, etc., usually using this new TK would not be an issue. Otherwise, you just use a new TU wall function. That would suffice, because that is actually based on the velocity profile. So, I guess new TU will be better. Okay, so let's go to original, new T, and I'll use the new TU instead. So do keep that in mind. I could not use calculated for the wall boundary conditions. I had to use a wall function. So that's a new TU wall function boundary condition. So please do take note. Alright. And there are a number of things. I see that this simulation is horribly slow. The execution time for one time step is see, this time step is actually like 589. The clock time is 590. But it's actually the max Courant number is 10, but it takes 10 seconds for every time step, and the time step is not exactly very big. You see the delta T is 0.0011. So to speed this up, I want to stop this simulation. I want to use a piezo algorithm instead. What do I mean by that? Okay, I need to go into, I'll just do an all clean. I'll clean everything up because I don't like this case. Okay, do make sure change the new T wall function. I made that mistake in the previous video. Okay, via new T. All right. So go to system, and I go to FE solutions. All right. 1 times 10 to the 5. I just want 3 iterations of this. Then that is enough. Okay, I'm not using a piezo type. I'm using a pimple type. So I want n order characters to be 1. N characters, I'll maybe leave it as 3. Okay, and I'll save and exit. I will not under relax anymore. Okay, relaxation factors actually help it to stabilize, but I don't want it to stabilize anymore. I want it to just be as per normal. This will actually make it go faster, but the catch is this: I need to keep Courant number below 1. So I need to go to control dictionary. I'll say the max Courant number is maybe 0.5 or something like that. So let's do a 0.5, and we can run the auto patch again. Okay, and of course I will have to change the other files as well. Okay, so yeah, while that is running, I want to introduce you to the other what do you call that, function. Okay, did I Alright, I realized I forgot to paste all these links in the last video, but do take a look. They should be in the description. Go take a look. Yeah. The other one I want to kind of take a look at is this thing called a, okay, you can take a look at a field average. Okay, field average actually gives you a time based average. Okay, or you can look at some other things as well. The idea is that remember we were talking about these conditions, these tile walls being very different for each patch. We want, or each phase, we want an average of all of these. So we need to look for a function object that actually helps us to do that. Alright, so I remember that there was one thing that helps you to do an average. Okay, and do a average. I believe it's a surfaceFieldValue or something like that. surfaceFieldValue. And what it allows you to do is to actually take an area average of all your stuff. Okay, so yeah, it allows you to take an average. You can look for the maximum, you can look for minimum. Okay, and this actually gives you the values at the surface, meaning to say if it's a boundary, like for example you want to measure wall shear stress, right? You want to measure wall shear stress, you have to look only at the boundaries. There's no point looking at wall shear stress within the fluid. Generally speaking, we are not interested in that. So we'll have values that are recorded at the surface. Alright, we have values that are recorded at the surface rather than within the fluid, and they're recorded at the surface. So that's why we use surfaceFieldValue to average all these wall shear stress values near the surface, and of course we will have a record of them over time. Alright, so let's see whether this thing is finished. It's done. Okay, very good. Now I'll just run a pimple foam in this terminal. Okay, right, let's see whether the max Coulomb number will drop. I hope it does not do anything funny. Anyway, so we'll let it run a few time steps, and you can see this is way faster. The calculations are going way faster. Okay, so we'll just let it run, okay, while we continue our discussion on these surface field values. Okay, so you can see the time step will hover around 5 times 10 to the minus 5. Okay, just to keep the Coulomb number within the acceptable limits, and it will just oscillate back and forth. Should not be an issue. Hopefully it's stable, because sometimes it can be unstable. But anyway, so these are the surface field values, surface field value that we want. And while it's running, we can actually change the control dictionary. Okay, we can actually change the control dictionary as the thing is running. Okay, so we go to System, you can go to Control Dictionary. Right, so don't mess it up too much, because if it's if we mess up the control dictionary when it's running, it will result in some sort of error. Okay, but anyway, this thing looks to be running fine. Anyway, we'll try not to have errors in this case. So what I want to do is to just copy everything here, and we will paste it in this functions. Okay, so everything is pasted. I want to say that this is okay. The first entry is this, which is actually the name of the function object. I want to give it something obvious, not obvious, something meaningful. Okay, so we have an average wall shear stress, for example. It's going to average it over the whole patch. So yes, the field we should have is this wall shear stress. So anytime now it should because okay, yeah, like I told you, we will have an error because yeah, we actually didn't change any things correctly. Okay, but okay, let's see. I want to start writing time steps like way faster. Let's say, yeah, I want to write time steps every 1 times 10 to the minus 2, for example. Okay, I'm going to write the time steps every 1 times 10 to the minus 2. But of course there'll be a lot of time steps. So so I won't actually want to, how do I put this? Yeah, why am I asking for more shorter time interval? So that, you know, at least the time when I'm stopping the simulation halfway, whether by accident or whatnot, it will be at least I'll still have some data to fall back on in that sense. Okay, there'll be some data to fall back on, and yeah, there'll be some data to fall back on, and basically we need to know what kind of field we are running our, we need to know what kind of field to look for when we do this averaging operation. So this averaging operation is remember I actually just commented all of this here, so it actually looks blue. All right, but anyway, I want to get rid of all this. I need to see what field I'm averaging. What's the name of the field? For example, if I know the field is called velocity, if you go to the 0 directory, if the velocity is called u, I need to type in a capital U here. Otherwise, I'll need to do something else. I need to look for this entry called wall shear stress. But how does the wall shear stress actually look like when it's being printed here? I don't know. So therefore, I will need to at least run it one time, then I'll know what it looks like. So now that I've commented out the erroneous portion, I can just start doing a pimple foam. So let pimple foam run for a while. Again. Okay, so it should be able to give us an output soon. So hopefully you know what wall shear stress is talking about. What I'm talking about. So we need to take a look, know what our fields are, and what is our operation type. So operation type, remember I was saying that we want an area average, so you have to copy and paste this area and average under let's say what is it? Under this operation. Yes, under operation we need to put area average. So okay, it looks like it's going to print out a time step soon. So let's see, where is my control dictionary? Alright, I need to edit that. Alright, so first thing first, I'll leave it in comments because you might mess up our simulation, which I don't want. Let's put operation type as area average. Area average. Alright, so that's what it is. Next thing, okay, so see when we change our control dictionary file, we'll have this this thing. PimpleFoam will say, yeah, I'm reading your file. So that's what we need to take note of. Anyway, the patch we want is a wall patch. We want it to be on the wall patch. Okay, so I'm saving it again, and look, it comes out, it will read. So this is like reading it on runtime. So post operation, I don't want any of this. This is not useful for this discussion. So I don't want any of this. Okay, right fields. What's right fields do? Name of field. Oh, what is a weight field? Well, right field will be in the here, I believe. Okay, never mind. I shall just ignore that. I can't remember what that is for. Okay, and whatever I don't know, I'm just not include it. Okay, it's not that important. Okay, right fields, I will take it out. Scaling factor out. Right precision, and that's fine. Right to file. That's kind of redundant. I wanted to give an output. So let's see. Because these are optional entries, so I'll just leave it out. Whatever I don't know, I'm going to leave it out. Okay, out. Okay, out. Now time start and time end, I'm just going to leave it out as well for the time being. Okay, what we want is the write time. We want to change the execute and write control to write time, because every time we print a time step, we want this function to be executed. So let's see what this thing looks like. Okay, this one let me write and quit. Let's go to, okay, it's still not printing out yet. Yeah, probably take a while more. I wonder how many cells this thing has. It's taking a pretty long while to calculate everything out. Polymesh, and let's say look at points. Oopsie. VI cell. Cell zones, no. Points, I guess. Oopsie. VI points. How many points do I have? Okay, 300,000 points. No wonder it is so slow. Okay, but anyway, we just fast forward this simulation a bit, and we'll see if we can know what the output file is like. Okay, so that we can see the field that we need to do the averaging on. Okay, so I'll fast forward this thing. And okay, hi, welcome back. So we fast forwarded and we have our first time step of data over here. So we can look in the 0.01 time directory. Okay, and then you will see this thing here, this field here called wall shear stress. So let's take a look at wall shear stress. Okay, so you see 42,000 points. Okay, 42,000 points, or 42,000 cells, 42,000 points of data. Then you'll see this wall shear stress. Okay, and this only accounts for the what do you call that? It only accounts for the surfaces, the walls. All right. In actual fact, if you take a look at the U, you have about 300,000 data points, which is why it's taking so long. Typically, the number of cells here is typical of a large eddy simulation. I mean, it's and usually 1 million cells is going to take very, very long time to finish. So you might not want to make it so long. Okay, but anyway, it's just for demonstration purposes, not really for anything else. So at least just get a flavor of what's going on, and looks like the simulation's rather stable. Okay, it's going to go into a second time step. So let's go to system. Let's quickly go to system. Let's go to system, control dictionary, and the thing that we want, the field that we want to do our area average on, is this field called wall shear stress. Okay, and then what I want to do is to delete this, and I want to delete this, and hopefully we won't have any syntax errors. So I'm going to write this in, I'm going to save it, and let's hope this simulation doesn't stop. Okay, it stopped. Alright, let's see where the where the errors are. Okay, So it's looking at blah 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 control dictionary line 282. No, it's not actually 282. Okay, so it says the right fields entry is not inside. Okay. So let's do a true for that. Since it's requesting for it, we want data to be written. I don't know what data this is, but let's just put it as true, just in case the stuff we need is there. Okay, let's run PimpoFOAM again and see whether this thing works. Okay, so it's going to give us another problem, and it says surface format not found. Okay. Right, I'll just say there's no surface format. Sure. So this is how I'm going to roll with it. Let's try again. And alright, looks like it's working beautifully. Alright, so let's see. There's a 0.02 file now. And there's also a post-processing file here. Well, then we can go and take a look what's inside the post-processing file. We'll see this average wall shear stress. Alright, we can take a look. Okay, time's up for me. It shouldn't take too long. Let's take a look at SurfaceViewValue 0.02. Okay, there's nothing here. Let's take a look at the other one. Nothing here as well. So probably it will take some time before you can actually go and check out what's there. Okay. Anyway, at least this shows you how to put in some of the interesting function objects. I hope this thing is going to work. So we'll have to stop for now. Then we'll take some time to see whether this function object is performing the right way that we want it to. Alright, so thanks for watching. I'll see you guys again. Goodbye.